HTI is proud to offer a unique waste-to-energy gasification process and high-temperature air turbine power generation technology. Our technology, incorporated into the gasification process, creates a more user-friendly, practical power system. The process starts with waste material being generated. HTI systems are compatible with over 50 different types of fuels. Turkey litter and wood chips are alternately used at this facility. The material is transferred to a series of conveyors that will move the waste to the gasifier. The material moves under a knife gate which levels the material for the optical moisture sensor. The moisture content of the material is recorded to the digital system controls through this optical sensor. Most waste materials contain moisture, with some as high as 80%. If the waste fuel has a moisture content above 10 to 15%, a dryer should be considered in the system design. Next, the material is weighed on a weigh belt conveyor before entering the gasifier. The HTI gasifier is based on a rotary kiln, a proven industrial machine with over 100 years of operating history. In the gasifier, material is heated to 1000 degrees Fahrenheit in a low oxygen environment. At these temperatures, with the absence of oxygen, the solids will turn into a combustible gas called producer gas or syngas. The residual ash oftentimes is of commercial value as a soil amendment or as a fertilizer substitute. As the syngas leaves the gasifier, it enters the cyclone, where the first stage of particulate removal occurs before the combustible gas enters the oxidizer. The oxidizer is the vessel with the HTI label. As this gas encounters oxygen and air, it becomes very flammable if exposed to an ignition source. In the full-scale system, the air is mixed in a very controlled environment with the syngas in the oxidizer. When the combustible syngas is mixed with oxygen in the air, it causes the gas to glow and heat to 2000 degrees Fahrenheit. When the gas in the oxidizer reaches 2000 degrees, the valve leaving the oxidizer is closed, diverting energy to the ceramic heat exchanger. This is the view of the ceramic heat exchanger when it is cold. In the background, you can see the glowing tubes of the ceramic heat exchanger when they are at operating temperature. This is where the syngas thermal energy is transferred to the clean air that powers the turbine. The air that powers the turbine is heated in a ceramic heat exchanger. The turbine air is compressed and forced through the exchangers where it picks up energy. From the metal exchangers, the air is then forced through the ceramic heat exchangers to pick up high-grade energy to spin the turbine. As the heat energy from hot, clean air enters the air turbine, the turbine is allowed to engage. The turbine spins the generator, creating electricity, which is transferred to a commercial electrical grid. After the turbine has used the energy it needs to make electricity, the excess hot air is sent to the boiler. The gas leaving the turbine is now back to 1000 degrees Fahrenheit and enters the boiler, where additional energy is captured through the creation of steam. On larger systems, a steam turbine is the preferred option for energy production. The final air quality treatment takes place in the wet electrostatic precipitator, also known as a WESP. The WESP is considered the best available control technology for maximum reduction of noxious gases and particulate matter that contributes to acid rain and air pollution. After all of the useful energy has been extracted, the remaining clean gas is discharged through the exhaust stack. The discharge gases that are of environmental concern are clearly missing from the stack gases of an HTI power system. On site, the system is digitally controlled with simple and intuitive graphical user interfaces. The system can also be controlled remotely on an iPad, allowing off-site support and total remote system operation. For small systems, some facilities will be able to run dark due to this feature. This completes the process and allows the biomass power system to achieve efficiencies of up to 80%.